Okay, in this video we're going to try to include everything that you're going to need to know completely about proportions. Now first off, let's read the problem. A bakery mixes 6 cups of flour for every 2 cups of sugar. So what we're going to do in our table here, let's go ahead and make a table. We got flour, we got sugar, and let's start with this ratio that they're giving us. A 6-to-2 ratio. Now keep a quick reminder that ratios can be written as a fraction, it can be written with a colon, or you can just write 6-to-2. So for every 6 cups of flour, we have 2 cups of sugar. Now, just like fractions, we can reduce ratios. So 6 and 2 are both divisible by 2. So we can reduce that down to, what if we only use 3 cups of flour? Then we're going to use 1 cup of sugar. So we have a reduced ratio. And one thing that I like to do is anytime I'm dealing with a ratio, I like to put a letter with it. So 3x and 1x. And I do this to show you something else. I want to give you some equivalent ratios. This x value can be any number I want it to be. What if x was 1? I have 3 and 1. What if x was 2? 3 times 2 is 6. 1 times 2 is 2. What if x is 3, 4, and 5? Now, what I'm going to do now is plug those numbers in and show you that all of these are going to be equivalent ratios. Like if I plug in 3, it gives me a 9, and it gives me a 3. What does that mean? What if I use 9 cups of flour? Then I'm going to use 3 cups of sugar. What if x is 4? You get a 12 and a 4. That's also an equivalent ratio. A 15 and a 5 is also an equivalent ratio. Now this ratio here, the 3 and 1, since you are comparing it to 1, is called a unit rate or a unit ratio. The word unit means 1. So anytime you're comparing with the number 1, how many flours for 1 sugar, that's going to be, again, called a unit rate or a unit ratio. So let's finish filling this out. It says if the baker uses 15 cups of flour. So what we're going to do here is look at our flour and decide what do we need to multiply 3 by to give us 15, and we just did that. Multiply the 1 by the same number, and if we use 15 cups of flour, we use 5 cups of sugar. Then it goes on to ask, what if we use 7 cups of sugar? Well, what do we multiply this by to give you 7? 7. So 1 times 7 gave me 7. 3 times 7 gives me 21. So what this does is gives me a list of exactly how much of one to use if I use the other one. Now let's go ahead and plot this on a graph. We'll look at the graph as well. So if I used, we'll let this be our f-axis. Let this be our s-axis, standing for flour and sugar. And I'm just going to sketch this graph. I'm not going to draw it exact. If I use 1, 2, 3 cups of flour, I'm going to use 1 cup of sugar. If I use 1, 2, 3 more, then I'll use 2 cups. If I use 1, 2, 3 more, then I'll use 3 cups. Now, something that's important about these equations, these graphs, is these are called direct. Anytime you have a proportion, you have what's called a direct variation. And if you were to draw this line, again, you have 3, 1, 6, 2, 9, 3. One of the most important things about these equations, if it's truly a proportion, this dot right here will always be on the graph. That dot is the dot that represents 0, 0. And that says, well, what if I don't use any flour? Then how much sugar am I going to use? That dot 0, 0 always has to be on that graph, or it's not a true proportion. Now, something else we can do. We can write a proportion as an equation, a proportional situation. Now, what we're going to do here is we're going to look at the relationship between our sugar and flour. And notice that there's always going to be some constant. It's called a constant of variation or a constant of proportionality, or actually slope, that tells us how to go from one variable to the other variable. Notice that 7 times 3 is 21, 5 times 3 is 15, 4 times 3 is 12. There will always exist some constant that you can multiply one of the variables by to give you the other. So my equation, I'm going to say the amount of flour that I use, I'm going to call it F, just like I did here. The amount of flour I'm going to use is going to equal 3 times the amount of sugar that I use. That's your equation. What equations are helpful with is, what if I want to know, what if I use 100 cups of sugar? Then I will use 3 times 100 or 300 cups of flour. It's always three times bigger. Okay, the last thing I'm going to show you is if something, again, if something is truly a proportional relationship, if it's direct variation, we can come up with the equation. It's always y equals some number times the x value. Then we can solve it by also using a proportion. The first part of the question said we use 6 cups of flour for every 2 cups of sugar. What we can do is we can say 6 cups of flour for every 2 cups of sugar. And if it's truly a proportional relationship, we can solve it like this. If this is the amount of flour we use, and this is the amount of sugar we use, we'll read the rest of it. It says, what if we use 15 cups of flour? This is the amount of flour we use. This will be the amount of sugar we use. Flour to sugar, again, that's a ratio, will always equal flour to sugar. And the way that we solve proportions, this is super, super simple. We simply take the numbers that are diagonal, 2 and 15, we multiply them, that gives me 30, and then we divide it by the other number. 30 divided by 6 gives me 5. And again, what that says is if we use 6 for every 2, then 15, then we'll use 5. There was our answer. The other part of the problem could be solved with if we use 6 for 2, same way we start out with the first part. 6 flours for every 2 sugars. What about 7 sugars? Flour, sugar, how much flour for 7? Again, to solve a proportion, 7 times 6 is 42. When you divide that by 2, you get x is 21, which is the exact same answer that we got there. Okay, I'm going to solve another one of these ratio problems. It says a printer prints 48 pages every 4 minutes. So 48 pages for 4 minutes. And again, I'm going to make a little table here just to hopefully make this make a little bit more sense. Now, the first thing I'm going to do is I'm going to reduce that. And I'm going to look for what we call a unit rate. 48 and 4 are both divisible by 4, so I'm treating this like a fraction. Divide them both by 4, and that gives me a 12 and a 1. That gives me a unit rate. That tells me that I can print 12 pages. If this is true, then I can print 12 pages every minute. So again, now what I like to do is I like to write that 12 to 1 ratio with variables, 12x, 1x. I can let x be anything I want it to be, and I can actually draw, let's put another couple more things on our table here. What if x was 2? Then that would give me 24 pages, and if x is 2, 1 times 2 is 2. What if x were 3? That says 36 pages would take 3 minutes, and so on and so forth. Now let's use the 12x and the 1x to actually solve the problem. It says how many pages are printed in 12 minutes? So again, here's my minutes. I ask myself, what do I have to plug in for x to give me 12, and that'd be 1 times 12. So when x is 12, that's going to be 12 minutes. 12 times 12 up here would be 144. So what that tells us, it would take 144 pages, or it would take 12 minutes to print 144 pages. And then the last part says, how long does it take to print 180? So our pages is 180. Again, we can figure out what we multiply x by to give us 180 by dividing, and that would give an x value of 15. So since x is 15, plug in x down here, and that would take 15 minutes. Now again, what we can do is we can graph this situation. And I'm just going to sketch this graph to where you have the number of pages and how many minutes it would take. So 1 page would be somewhere right in here, would take like 12 minutes. 2 pages would take 24 minutes. 3 pages would take 36 minutes. But again, the most important part is when you graph these things, okay, make sure that 0, 0 is going to be a point on that graph. What if you print 0 pages? How long would that take? 0 minutes. That confirms that it's a direct variation equation. Now, to actually come up with that equation, we can actually look right here, would be the easiest way. There's got to be some number I can multiply my minutes by that gives me my pages. So 1 times 12 is 12, 2 times 12 is 24, 3 times 12 is 36. So instead of y equals, let's do this. Let's say the number of pages I can print is equal to 12 times the number of minutes that I actually print. So you can plug in, just to check this, you can plug in 12 for minutes. 12 times 12 gives you 144 pages. So therefore, there's you a direct variation equation that you could use to figure out the relationship between pages and minutes. Now, one last thing, just to remind you that anytime something is a proportional relationship, you can solve it with a proportion. Now, how do you know it's a proportional relationship? It's linear. meaning it's going to be a line. There's going to be a direct variation, meaning that there's going to be some number times one variable will always give you the other variable, and it will always pass through the point 0, 0. So let's try to use a proportion here. So 48 pages takes 4 minutes. That's a ratio. You can use any of these ratios. They're all the same. If 48 pages takes 4 minutes, now this is important. Pages on top, minutes on bottom. If 48 pages take 4 minutes, how many pages are printed in 12 minutes? Now, since minutes was on bottom, I'm going to put minutes on bottom over here. 48 pages, 4 minutes. How many pages? 12 minutes. To solve a proportion, you to multiply the two numbers that are diagonal. So we're going to do 48 times 12. We're going to divide that answer by 4. And when you do that, you'll get an x value of 144, which is the exact same answer that we got up here.